Welcome to Akbar Academy. Today we are going to be doing the 2021 Paper 4 Variant 1 question number 2 for the 0625 IGCSE syllabus. And the question is all about momentum. So figure 2.1 shows a wooden trolley of mass 1.2 kilograms at rest on the rough surface of a bench. A ball of mass 0.52 grams travels horizontally towards the trolley. The ball embeds itself in the wood of the trolley. The trolley moves off with an initial speed of 0.065 meters per second. The first question says, calculate the impulse exerted on the trolley. Well, see what's happening here is when the ball actually hits the trolley, it embeds itself within the trolley. So basically, the total mass is actually now gets slightly bigger. Very small is the mass of the ball, but it is now part of the trolley. However, the first question is specifically asking about the impulse exerted on the trolley, and the formula for impulse is Ft equals mv minus mu. Now, the thing is, the trolley is not moving at the beginning, so the impulse at the beginning for the trolley is 0. But the mass of the trolley is 1.2, and they've told us that the trolley moves off with a speed of 0.065. So if we stick this in, so it's 1.2 times 0.065, and that's going to be subtracted by 0. And if I stick that in my calculator, so 1.2 times 0.065, I get 0.078. So the impulse is 0.078 Newton seconds. Where did I get that from? Well, force is measured in newtons, time is measured in seconds, impulse is Ft, so it's Newton second. Now, you are allowed to use kilogram meter per second, but I tend to suggest to students stay away from it because the formula for momentum and impulse can then be confused by the student. Next, it says, what's the speed of the ball as it hits the trolley? Well, this is where the conservation of momentum comes in. Total momentum before the collision is equal to total momentum after the collision. So, total momentum before equals total momentum after. So, what was the total momentum before the collision? Well, remember, the little ball's actually embedded itself into the trolley. So basically what we've got is we've got mass times velocity, but before, right, as it hits, when it hits into the trolley, it says it's embedded itself. So basically what the mass is 1.2052 kilograms times 0.065, right, which equals the mass of the ball, which is 0.00052 times v. Okay? Now, why did I do this? Remember, they gave us the mass of the ball in grams. It was 0.52 grams. To change that into kilograms, we've got to divide 0.52 by 1,000. So the total momentum before is 1.20052 times 0.065, which equals 0.00052 times v. And if I just rub that out and rearrange, what I'm going to end up getting hope you're following this. What I'm going to end up getting is 1.2 0.0052 times 0.65 divided by 0.00052. Now remember, this is because it's in grams and I've got to change it to kilograms. I divide by 1,000. So if I plug this into a calculator, I get 100. I've done something. Let me just check that again. 1.20052 times 0.065 divided by 0.00052. Yep, I just added an extra zero there. So it gives me 150 150.65 meters per second. Now, you're welcome to round this. Okay, you're welcome to round it up to 150.7 meters per second. You're welcome to round up to 151 meters per second. There's no problems with that at all. At IGCSE, it's not a big deal. Now, part B. As the trolley moves across the rough surface, it slows down and stops. Explain in terms of the work done, the energy change that takes place as the trolley slows down. Now they've mixed energy in with momentum. Now, anything that slows down is going to slow down due to friction. And wherever there's friction, there is always thermal energy. So basically, the trolley is doing work against friction. So we're going to end up having thermal energy, and that's where the energy is being transferred, if you like. In the old syllabus, we would normally call it wasted, and that's why it slows down. So let me write this down for you. Work done against friction. Let me just do that again. Might as well just do the whole thing. Against friction. Okay. And then kinetic energy decreases. Kinetic energy decreases. Thermal energy produced.